So today we are going to find the average rate of change of a function and use that value to find a secant line of the function. Now we're starting with a word problem, and we have a hill and a lake, and there's a zip line that's mounted to the hill and ends in the lake that kids can slide down. For safety, the slope of the zip line cannot be steeper than -2/3. The hill and the lake can be described by this equation, y equals e to the -x plus 1, and it's only true for x greater than or equal to 0. So you can see there, after x equals 0, all down here, this flat part is the lake, and this part right here is the hill. Now we can assume that the zip line begins at coordinate x equals 0, and it ends 5 meters away, so we'll say that it ends at x equals 5. Now we're going to use that information to find the average rate of change of the function that describes the hill and the lake from 0 to 5. First, we need 2 points, which we already have the x coordinates of. We have 0, y1, and 5, y2. Now we need to find the values of y1 and y2. y1 equals e to the -0 plus 1. So y1 just equals e, which is about 2.72. And y2 is e to the -5 plus 1, so that's e to the -4, which is about 0.02. Now we have our 2 points, 0, 2.72, and 5.02. We can use the average rate of change equation to find the slope of our line. And now we plug those values in for y2, y1, x2, and x1. And if you evaluate it, you'll get -0.54. Now that we have the slope of the line and 2 points, we can use a form of a linear equation called point-slope form to write the line. That's y minus y1 equals m times x minus x1. Now we just plug in our values. We found that y1 was 2.72. We found that the slope of our line, which is the average rate of change, is -0.54, and that x1 is 0. We can rearrange this into y equals mx plus b form, if you'd like to simplify it to that. But since we know that the slope of the line is -0.54, which is less than the limit of -2/3, or -0.667, that the zip line is safe.